Hello. So this is an introduction to Lab 7. This may be helpful to you just because there's a lot of kind of moving parts in this lab. Can be kind of difficult to understand where to start. So yeah, I just want to give kind of an introduction to show you where I was thinking when going through with this lab. So the first thing, so here is ESP IDF. And so we can see in the examples folder that inside this we have protocols, and then we have HTTP request. And so we're going to be spending a lot of time in this. But first, let me pull up the labs just so we're able to look at this together. Okay, great. So here is Lab 7. So Lab 7, it is to make a weather station that is run on the ESP32. And then this weather station then posts the results to some server. And in this case, like it's saying Raspberry Pi server, in this case, in this lecture, I will actually show you how to put it on your phone instead. I think it'll be a little bit easier with that. So, okay, the first thing, so part 1, it is mentioning this on this really great resource that it's an open source project that creates like a way to gather weather data really efficiently. So we can go to this GitHub page and we can read all about it. It's saying that we can access the weather, and here's the command right here. So it's saying we can just run curl. Curl stands for something, but then it's like something URL. So like grabs whatever URL. So we can grab this, and then I can open up a terminal. We can see what happens when I run this command. So if I just curl the weather, and let's do it in London. So if I run this, then we should see, well, this is awkward. Okay. There we go. Okay, just took a second. There we go. So it grabbed the weather for us. So it's saying, yeah, whatever. I guess there's light rain in London right now, and it's showing wind direction and as well as other just important information related to the weather in London. Really great resource. We can put in all sorts of things. We can put in Santa Cruz. We can put in wherever. And in fact, we can look at all of the different functionality that this service has with this help page right here. So we can curl for this if we want. There we go. So if I now paste this in, then this will give us all of the different parameters that we can mess around with. And actually in this lab, as you read a little bit deeper, you'll see that you will need to just grab the temperature data, I believe. And the temperature data, it's somewhere in here. Now I can't find it, but yeah, and somewhere you can just give report just like Celsius and whatnot. And yeah, okay, so very cool project. Highly recommend kind of looking through it. We'll pull up the source code for it in just a little bit, but okay, great. So we have this website, and I've shown you that it's really easy to run. Let me close out of this. It's really easy to run curl and fetch this data on a computer. But of course, we are not going to always have a computer with us. Like if we're like a whole like Windows machine, Linux machine. The goal of this is to perform curl, except on our ESP32. So what we can do then is we can go back to this HTTP request example that's provided here, and we can kind of look through this and see exactly what is happening here. And and first maybe it would be best to just kind of run this. And so let me just start. Let me just try running this. So it'll be idf.py flash monitor. Okay, and while this is compiling, I think it'll take a little bit. I do want to mention one thing, and it is that like the ESP32 needs to connect to a Wi-Fi network. Like there's a Wi-Fi chip, Wi-Fi module on the ESP32, and since we're using Wi-Fi, of course, if you've ever connected to a Wi-Fi signal before, you need to provide an SSID and you need to provide a password. And in this example, it's a little bit obfuscated, but the way that you're supposed to do this is by inside of the SDK config .defaults, or you can put it in a different file. You should put in this these parameters right here, which are config example Wi-Fi SSID and password. And so for my hotspot right here, which I will start in just a second. I guess it's already started. I have put in the name of my hotspot, and I've also put in the password. And this is just a temporary password that I've set for this example. So yeah, please don't hack me. Okay, so here is here is my Wi-Fi password and thing set up. And so I just compiled this and I ran it, and it turns out that by running this example, I've done nothing. We can see that it looks like it's grabbing something. It looks like it's pulling up an HTML page. So let's go back to what this is, what is happening. Yeah, okay, so it looks like it's going to this example.com URL. If I go to this example.com URL, okay, so we see example domain. This domain is an illustrative example used for illustrative examples and documents. Okay, let's double check that that's actually what we are receiving. So yeah, so it looks like we are in fact receiving an example domain with with everything, and cool. So this domain is for use in illustrative examples in documents. Great, perfect. So we have now successfully done an HTTP request with our ESP32. This is very cool. We've now done like a fetch. So yeah, if you wanted to, maybe like you make your own web server that just like is constantly pulling data from something. This is how you do it. You start with this example, and then we get going. So let's now go, and instead of fetching example.com, if we go back to what the lab is asking us to do. So the lab is asking us to pull the weather data from this site. Okay, so what I will imagine then is I can just copy this site. I can just paste that in right there. And so now in theory, so if I close this and then rerun it, so now I am recompiling, but the only difference is now I'm grabbing it from this this domain now. So let's see what happens. Okay, it's almost done. Takes kind of a while, but good. Okay, so it looks like it's still connecting, and there we go. Okay, cool. So once again, we have successfully received some HTML. But if we look closely though, we actually see no, it's not that great. It says moved permanently. This document has moved here. Okay, so it looks like it wants us to fetch this URL instead. Unfortunately, it looks like we can't just grab this like wttr.in. Instead, it wants us to use HTTPS. HTTPS. So maybe this is a good kind of moment to explain what HTTP is and HTTPS are. So HTTP. Let me pull up the acronym because I don't remember it off the top of my head. Acronym. Yeah, so HTTP is called the Hypertext Transfer Protocol. And hypertext, if you are familiar with web development, you may be also familiar with the hypertext markup language, also called HTML. All websites are made out of HTML. And so this HTTP, this Hypertext Transfer Protocol, the whole purpose of it is to send website data from one computer, or like a server, from one server to some peripheral server or some peripheral device. So HTTP, this is one of the most popular internet protocols, one of the most popular protocols in the world. The whole idea with it, is that you're sending data across the network. And but then HTTPS is a little bit more complicated. So it's the same, it's Hypertext Transfer Protocol, but it's now labeled as secure. So the whole point of HTTPS is now there is a certificate that is compared against on both the host and the peripheral, and there needs to be there's encryption involved, and it's really great. And basically every single website now on any modern browser will like strongly enforce that any websites that you go to must be using HTTPS, because like if you are on like a banking website, you don't want your bank information to be sending you data through HTTP, because HTTP is completely unencrypted. And so if I like stuck an antenna in the air and was listening, sniffing like the Wi-Fi packets, what I would actually see is I would see like exact like banking routing numbers and like transactions. I could see the exact bits like in just raw ASCII, and I could see exactly what is happening. And so this is a very dangerous protocol, HTTP. It was totally fine back when like we were just using the internet for like very basic blogs and forums. But basically in the past 20 years, HTTP has been almost completely deprecated. Now everything is using HTTPS, which is, means that everything is secure. Okay, cool. With that said, in this lab, I recommend just using all entirely HTTP. You're welcome to try HTTPS, not too much more complicated, but it adds a couple extra steps that, in my opinion, are not like the most crucial. So instead we're just going to use HTTP. But that's an issue though, right? Because if we go back to what this error said, so this error says that the document was moved to the HTTPS website. Obviously makes sense, right? We want every single website to be encrypted and secure. But what we'll find, like if we try running curl on this, so if I run curl and then paste this in, so if I actually did HTTP with curl, then you might expect that we actually get the exact same result, right? You'd expect that we would say like, oh, please use HTTPS. But if I hit enter, in fact, what we see is like the weather data. So that's kind of interesting. And this, took kind of a while for me to figure out. And I know some other people were kind of stuck on this. The reason for this is actually a decision from the makers of this weather website to specifically allow curl to use HTTP, which is fine because like curl, like, I don't know, but I think it's basically for debug purposes. So it's and plus it's not like a bank, so it's okay that we're using HTTP. Plus browsers usually get mad at HTTPS, but curl will not get mad at HTTPS. So but let me just quickly show you. I found it in the source code exactly where the issue is. So it's already pulled up. Let me just confirm with you. So this is the source code for this weather project. Cool. So we can see everything. What I noticed though, so if I search for curl and cut some of this stuff out, so I don't need docs, any of this. I don't even think I need. Wait, hold on. Sorry. Let me remind myself where I found it. So I think if I search for like .python files, so this is interesting. So curl is actually specifically mentioned in the source code, and it's mentioned in the source code right here, plain text agents. And if we go to plain text agents and search for plain text agents, then we'll see right here, that HTML output is like depending on our plain text agents, and effectively, like we can go deeper into what this means, but effectively what this means is curl is whitelisted to use HTTP. So that's great, because what we can do then is just pretend like our ESP device is actually curl, and that is done right here. So here in the source code for this example, we can specify in this request that we have right here, we are requesting data from this server, and then we are saying like, hey, we are an ESP device. But what we could also say is like, maybe as like a fallback as well, we could say, hey, and also like we're also pretending like we are a curl device. So we can just add curl here. And now if we do this, then in theory, everything should be fixed. So I can now run ESP flash monitor one more time. And so now we should see that it successfully works because curl is whitelisted for this request. All right, so let's see. Okay, so now it's connecting to Wi-Fi, and there we go. Okay, great. This is fantastic. So you can see example 987, whatever, it's resetting, but you can see it's now successfully grabbing the weather data, which is great. That is, I basically just showed you how to do part one of the lab, grabbing the weather data using an ESP32. So the, okay, cool. But let's look a little bit closer what this example is actually doing, right? Like, so, like, how do you even connect to the internet? Like, how do you do requests? How can we send out this message? So we can see, yeah, we have this request right here. If I search for this, okay, cool. So it's writing this request. It looks like to a file, right? Write is for files. Here you put in your file descriptor, if you're familiar with file descriptors from operating systems. So here we have our file descriptor. So we can look at where this file is opened. And yeah, okay, so we can see this file. Oh, weird. Okay, so it's saying this file is equal to socket. And then inside this, it's doing whatever family socket type. Okay, so that's weird because I thought S should be a file, right? Because this is right. It turns out that a socket is the data type that is presented to the user, to the developer of someone who's writing a web application in C or really for any like operating system at kind of a lower level. So a socket looks like a file to the user. Like when I want to access data, when I want to like use a socket, what I do is I will use these file descriptor methods. So I can do write, I can do read. A socket is basically just a file. And this is great because now we can perform requests and it's all abstracted away. All we have to do is just do write, and then magically it kind of just sends this request. And we can also look at explicitly like what this request is. So yeah, we can see, so it's doing get, okay, whatever that is, but then HTTP, okay, so it looks like it's using HTTP protocol, and then yeah, it's fetching this URL, okay, so this kind of makes sense. So what this request is this is an HTTP request, specifically using the get mode. So there's another important mode called the post mode, which I will show you in a little bit. So so using get and post, this is kind of the main way that internet traffic is kind of sent. But let's just really quick. Let's go back to the lab just so yeah we can figure out exactly what is the next step here. All right. Cool. Okay, so here's the lab. So good. So we've fetched this data, very successful. The next thing though is it says you must read the temperature and humidity sensor. Okay, that's easy. You've already done that in previous labs. But then it says create an HTTP post. Okay, so it's similar to get, except it would be post. Okay, so create a post against the IP meaning like internet protocol address. So IP that provided the hotspot, so that like of the phone that you're connecting to. Okay, and the ESP should send a post every second to this IP, and then the phone should display the information when the post is realized. All right, you're like, yeah, what does this even mean? So what we're going to need to do first is we will actually need to set up a server on our phone. And when we have a server set up on our phone, that now means that our ESP32 can now do requests on our phone. So we've finished the weather part. We've already gathered the weather data, but now what we need to do is have a entirely separate request. And we want this separate request to, instead of grabbing it from this website, instead we now want to post data to our phone. So now the phone is receiving the weather data from the ESP32. Okay, before we worry about post though, let's just try to get data from our phone, because it's a little bit easier, because now we don't need to like also worry about the data that we're sending. Okay, so first, yeah, let's try to get working. Okay, so just 1 second. Maybe kind of de-fingerprint this. Okay, so hopefully you can see this okay. We shall see. Okay, so I have this this cool app that I just downloaded, and it is called ISH. Let me pull it up in the App Store, actually. I'm on an iPhone. I assume that there are similar apps for Android. But okay, so let me just double check. Okay, so here is ISH. And if I open this app now, what this has is basically just a Linux terminal. Let me turn down brightness a bit. Yeah, and so inside of this, I can start an HTTP server. And the way that I can start an HTTP server is with the command, just kind of basic. So first I had to install Python. I think that was done with apk add Python 3. So if you are using ISH on iPhone, it could be the case that ISH exists for Android. If that's the case, then that's great. You can just use these commands directly. But so first I installed Python, and then I had to start a web server by running Python 3, and then I want to run the module that comes with Python called http.server. And what this will do is it will basically just run a very bare bones server with like no functionality, but it will just pose itself now to like kind of to my local network. So let me run this command. So I'm just going to quickly type this in. So Python 3 -m http.server. Okay, so I just typed in this command, and then I will hit enter. And there we go. Okay, so it has now started a website. It has now started the server. I can now access this website I can access this as a website on my on a browser on my phone. So I'll just quickly double check that. Okay. Good. So it accidentally loaded too quickly, but I just went to this URL on Chrome. So you can see it's 127.0.0.1, and it's on port 8000. And so I just loaded up this website, and you can see that it loaded up just kind of this bare bones website. It's just ASH history. So cool, whatever this is. Anyway, so this is the target website. So this is what we are hoping to get. But before we maybe try getting it with the ESP32, let's just double check that it works on our own computer. So the way we can do that is we need to now find the IP address of our phone, because by finding the IP address of our phone, it will now let us connect to it. Remember, so before, like, we were connecting to this address right here, which is the weather data. Instead, we want to connect to the IP address of the phone. So I opened up settings on my phone, and your phone may be different, but I opened up settings and I open up Wi-Fi, and then I can go into my Wi-Fi settings by pressing this little I button. And then if we scroll down, then now we can see that there is this section right here that shows you your IP address. So in my case, it is 169.233.200.2. So that is my IP address for my phone. Before we try doing anything with the ESP32, let's see if this works. So if I just type in that address, so 169.233, it looks like I already have it pulled up, so hopefully this just works. I'll hit enter, and let me just double check I'm connected to the right. Yeah, I'm connected to this. All right. Oh, you know what? It's because I'm not on the server anymore. There we go. Okay, perfect. Yeah. So in order for the server to actually run, you actually need to have the app running. So that's why it wasn't loading, is because I had the app open in the background. So there we go. Okay, cool, great. Can I move my? There we go. So yeah, we can see the directory listing. That way, yeah, my face isn't blocking it anymore. This is very good. This is very good. Now we know for certain that this IP address, in fact, is leading towards this web server that is running. So let's now test this in the ESP32. So I can paste this in, and instead of port 800 or 80, it is now port 8000. Cool. So let's now try running this. So in theory, when we run this, it should, no, what's going on? Oh, my bad. Yes, I just need to CD in the correct directory. Okay, CD there, good. Okay, flash monitor, here we go. So now the ESP32 in theory should connect to my server, and so we can see, you know, I'll just hold this up so we can see it at the same time. All right, hopefully, okay, still connecting, and there we go. Cool, it looks like it is grabbing data. Yeah, cool. I think we'll get another one in a second. Yeah, so there we go. So we see another line. We can see this get like request. And if we look at what we received, there we go. We see this like ASH history file, and we see like everything. This is great. Awesome. We are now successfully connecting our ESP32. I don't think I can pull it, whatever. The cable's too short, the one that they give you from Bell's, but oh, there we go. Okay, you can just barely see it. Anyways, ESP32 is now actually connected to the web server that is running on my phone. This is fantastic. Our IP address is working now. Okay, great. But instead of just getting this data, of course, the whole idea is that after we fetch the weather data, we now post it to the phone so that then the phone can print out that data. Okay, so let's do that. And instead of get, what we will need to do is post. And I prepared ahead of time the code for this example. So let me just paste this in. So yeah, so instead now X task create, we're doing this HTTP post task. And if we scroll up, then yeah, now we can see, so here's our IP address that we already established ahead of time. But then here, I am now sending this payload right here, which is hello world. Instead, the payload will be your weather data and also humidity temperature sensor. But in this case, I'm just doing hello world. And then here is the what the data will be for post. So yeah, we can see post still using HTTP. And then here we have the user agent. I've removed curl because it's not really important here. We're doing content type text plain. You're welcome to change this. Content length is set to %d, and then the data is %s. And if we look at where this is used, then yeah, so I guess first, so we calculate the length and then copy this into this buffer right here, this request buffer. But then we can send out this request buffer. And also, so here is now the string length. So that was passed into the %d input. Hopefully you're familiar with like the printf kind of formatting. standards. So %d in this request template takes in string length and embeds it into the string. And then post payload takes the replaces the %s that is in this request template. So yeah, okay, cool. And then we go and we write this all out, and we write it for every single bit, and there we go. And so this, in theory, should send out the data. So we can try running this and seeing what happens. I don't think it'll be too interesting, unfortunately, because I don't think there's really a great, we'll actually see what happens. I don't know if I've tested it this way, but okay, we'll see what happens. Okay, so it's running. Okay. So, oh, fantastic. Okay, great, cool. So yeah, so we see on our server, it's a little bit hard to see, but it looks like we actually did receive the post command. And there we go. Yeah, the only issue is just it says unsupported method post. Okay, that is what I was expecting, because the generic, very basic web server that we are running, the like http.server does not support post. So that's totally fine though. We can just add functionality for post. And this is something where I asked ChatGPT, and I was like, hey, ChatGPT, can you just give me a basic server file written in Python that uses HTTP server and then has a basic get handler and a basic post handler. And I just asked ChatGPT to make this for me, and it honestly worked first try. You're welcome to kind of copy this down, or maybe try playing around with ChatGPT, try to put in a good prompt, and it should spit back something like this. Yeah, and we can quickly check what's happening. So it looks like when it receives a get response, so this will run on the phone. So we need to send it over to the phone, but this will run on the phone. And so when the phone receives a get response, then that means that now it will send the content that it I think it's just kind of blank content. Versus if instead the ESP32 sends a post request, then in this is a little bit more interesting. Then now we can read out the content, and then we can display this data, and it'll be like received post data. So in theory, we should see received post data equals hello world, and then after we should see like post request received. So in theory, this is what we should see on our phone when we run this on our phone. And I actually already copied over this file. Let me actually close out of this web server. Let me show you on this app, in case you use it, how to close out of this. So you may notice on your keyboard there's no Control-C, no Control-Z. Like you can't really kill this. But what you can do is there actually is control functionality. It is this caret right there. So if I press the caret, then now it is filled in. Then I can press Control-C to kill it. So I just pressed Control-C, and there we go. It just killed it. And now I can go and show you the server file. So I will really quickly do that. So so I have Nano installed because I like it more than Vim because it's just easy. So I typed in the first two letters. I can use tab to autocomplete with this tab symbol right there. So if I press tab, then there we go. You can see it tabbed out to server.py. So this is a file that I literally just I emailed myself this file, this server.py. I emailed myself this file and then copied the contents and then opened up server.py in Nano and then pasted in the contents. It's pretty easy to just get some sort of file into this. There's probably better ways, but I just copy and pasted the contents of this file from an email into Nano running on my phone. Works totally fine. But and then if we run nano server.py, we can see, so here is in fact like this file, and we can see that the do get and the do post. I can close out of this. So finally, after all this, now in theory, we should be able to run Python 3. server.py. Okay, so I've just typed in Python 3 server.py. Okay, and if I run this, okay, starting server, and okay, it looks like it got a post. And I think in just a second, it'll get something else. Okay, great. Yeah, and then we can also see info received post data hello world. That is, in fact, the data that we are sending out on our ESP32. Where is it? Yeah, hello world. Great. Do you see that? So let me show you one more time. Great. Hello world. Very cool. Okay. So with all this, let me just double check. I think I've now kind of covered everything. So this, I think, should be kind of enough for you to get started on. Yeah, so that is kind of part 2 as well. So it says, yeah, should post out to your server, and then the server should display out that information. So in this case, I'm just displaying the simple text, which was hello world, but I could easily send the weather data right here. Okay, and good. So is that all? I think so. Oh, you know what? This is the final thing. So okay, grid. The very final thing that we need to do. So it looks like this command should run on your Pi/phone, and this will. So your phone should figure out exactly what it should figure out what location the weather should be calculated for. And so there are a few different methods for this, but you can kind of just Google around, say like, honestly, yeah, we could ask ChatGPT, I guess. We could say like, how do you wget your like current location? Is there a project that does this? Okay, I have no idea what's going to happen here. Actually, I forgot to prepare this in my lecture notes. All right, let's see. Geolocation app. All right, this looks great. Okay, let's copy this. Let's test this. IP info. Okay, great, perfect, awesome. That's close enough. Cool. There we go. So, and you can just parse this out. This is JSON. So we can just be like, oh, like write me a JSON parser that will now grab me this these coordinates or something, and then it'll grab these coordinates and then plug it into the weather solution. So okay, cool. I've basically walked through how to do every single part of this lab now. So if you have any questions, please let me know on Piazza. But in theory, this should be good enough for you to get started on. So, all right, good luck, everyone. And yeah, let me know if you have any questions.